Alright, so now that we've learned about geometric series, we're going to do some notes on how to find the sums of different geometric series. So just like we learned about arithmetic, and then we learned about how to do sums of those, we're going to go through a few different situations. So we're going to try to recognize whether it's geometric or arithmetic, identify if it's infinite or finite. Those are two different types of series we have. And I'm going to find the sum of infinite series and find the sum of geometric. So first, let's start with a little bit of review. Remember that this means I start at 1 and I end at 4. So I need a 1, a 2, a 3, and a 4. Alright, so my first term, 20 times 0.2, 1 minus 1, 20.2 times 2 minus 1, 20.2, 3 minus 1, and 20 times 0.2 to the 4 minus 1. So simplify these a little bit, again by hand, 20.2 to the 0, 20.2 to the first, 20.2 squared, and 20.2 cubed. Again, this is where you'd go to your calculator, enter them in to kind of find what it equals, and we'll get some things here. So we've got 20, this is going to be 4/5. Now, anytime we're doing these, you want to try and keep them as fractions as long as you can. Alright, so then 4/25. Remember, sigma equals sum, so we need to add the terms together. 20 plus 4 plus 4/5 plus 4/25. Well, in your calculator, do that. So the sum from I equals 1 to 4 of 20 to the 0.2 to the I minus 1 is 624 over 25. And that is your answer for that. Well, what about this next one? Look at this. We start at 1. We go to 100. That's 100 terms that I need to find. Do you really want to find 100 terms? I hope not. So, again, need to find 100 terms. That is a lot of terms to find. So, what do we need to do? Well, there's a formula. There's actually two formulas. So let's talk about it. Remember, a geometric series is what? When we are multiplying or dividing by the same amount for next term. Well, there's something else that we need to think. Well, what about if it starts as like the summation? So in sigma notation, we look for exponents, because geometric series have exponents. Alright, so what do? Our goal is to add all the terms together. Add them. We don't want to find all the terms. So, like this example here, we're not going to want to find all the terms 1 through 100. We just want to add them together. So, there's two types, again, like I said. We have infinite and we have finite. So, finite and infinite are two different types here. A finite is used when there is a set number of terms. So basically when there's a beginning and an ending. So examples here are 2 minus 10 plus 100 minus 500 plus ... plus 625,000. That would have a start and an end. So that's an example. Alright? Next one would be one in sigma notation, with n equals 4, ending at 15. 6 times 1/2 to the 2n. So that has a start and it has an ending. So therefore it is finite. What about infinite? Well, infinite, the only difference here now is that we're talking about something that doesn't end. So use when given a never-ending series. Basically, you're looking for infinity, or you're looking for the ... But the ... has to be the last. So, for example, we're going to use 2 minus 10 plus 100 minus 500 ... So notice I didn't have an end term here. Yeah, they're the same kind of series, but I didn't end here. Or we're going to do n equals 4 to infinity of 6 times 1/2 to the 2n. So again, notice we're looking for that infinity or that ... there. Alright, let's put this into practice. Let's figure out how we do these. Or, let's give some formulas to you guys. So, finite, again, that's going to be the sum of terms where we have a ending and a starting and an ending. So equals a1 times 1 minus r to the power n divided by 1 minus r. When you do these in your calculator, you have to be very careful as to how you enter them. Alright, so Sn stands for the sum of n terms. N stands for the number of terms. A1, of course, is your first term. R is your common ratio. And let's talk about finite, or infinite. The sum is a lot easier. It's just a1 over 1 minus r. However, there is a restriction on that. You can only use this when the absolute value of r is less than 1. And this is the sum of all terms. So whenever you see an S, it's talking about sum. And then you need to figure out what kind of sum it is. Alright, let's do an example or two, so then you can try some. Alright, so let's get some rules down. First, we need to find the first term. So example 1, first term, a1 equals 1 over 25. It's usually the easiest thing to find. Step 2, we need to find the common ratio, if there is one. So first, let's figure out if this is even geometric. So is it geometric? How do I know? Well, am I multiplying by something to get the next term? Well, 25 times 3 is 125, times 3, or times 5 is 125, times 5 is 625. So yes, I have an r equal to 1 over 5, because I needed to keep it as a fraction. So r equals 1 over 5. Next thing I need to do is, common ratio, some things to talk about. Again, that's the amount multiplied by or divide as a fraction, or it could be the number raised to exponent. And why do I talk about that? Because this number raised to an exponent is right here. So r equals 3 in this case. a1 is your 4. And that's because you have an equals a1 r to the n minus 1, if you recall your geometric. Alright, next thing, if finite, find number of terms. So basically we need to find n. So let's look at these two series and determine if they're finite or not. Well, looking at this series, it ends with a dot, dot, dot. So that tells me that this series is not finite. This series is infinite. But if I look at this next one over here, I start at 1, I end with 15. So that series is finite. So how many terms are there? Well, n equals 15, because I have 15 terms total. Alright, and the next, and your last and final step is to simplify. In your formula, whichever one you used. So, infinite, I need to use the sum equals a1 over 1 minus r. So the sum, a1 is 1 over 25 over 1 minus 1/5. Now, be careful in your calculator when you enter this. You want to make sure you use a lot of parentheses. 1/25 divided by 1 minus, fractions always go in their own set of parentheses. So 0.5. But since I have all fractions, I want to make sure I turn that into a fraction. So go to math fraction, and you get 1 over 20. So the sum equals 1 over 20 for this one. Alright, now let's go in and do this one. Sum of 15 terms, a1, 1 minus r to the 15th power over 1 minus r. Sum of 15, a1 is 4, 1 minus 3 to the 15th power over 1 minus 3. Again, with this one, the way I'd enter it is I would start with the top 4 parentheses 1 minus 3 to the 15th power, and then I would divide by 1 minus 3. I'd break it down into 2 separate steps. Alright, so then we get the sum of 15 terms is 28, 6, 9, 7, 8, 1, 2. Alright, so that is those 2 problems there. These 2 examples down here, again, these are try on your own. So figure out, again, your A1, figure out your R, figure out N if you have to. Here, focus on that little infinity sign, that tells you something. You might need to find N in this case, and you go ahead and figure that out using these new formulas. And I will continue the next set of notes in a separate video.